And welcome to this section of the course. This section of the course is on VPCs, and in this lecture we're going to do a VPC overview. Now, a word of warning, VPCs is fundamentally one of the most important exam topics no matter what associate course you're doing. So if you're doing the Certified Solutions Architect Associate, Developer Associate, or SysOps Administrator Associate, you need to know VPCs inside out in order to stand a chance in passing your exam. So we do keep this section of the course the same across all three associate courses, and the reason for that is like I just said, you need to know this inside out in order to be able to pass any of the exams. Now the good news is that the questions that you'll see across the three exams will tend to be very similar to each other. It's all around networking, subnetting, or security controls, all of that. So we will cover this off. This section of the course is going to be very, very hands-on, so you're going to go in and build out your own VPCs, and you're going to learn an awful lot about networking. At the end of this section of the course, I really want you to go out and build out your own VPC by memory. You really shouldn't go into doing the exam unless you can build out a VPC by memory. The great news is, though, is by doing this section of the course, you are actually really preparing yourself for all three associate exams. So you might want to just go on and do the other two because you've captured a lot of knowledge from this section of the course. So let's go into what a VPC is. I want you to think of a VPC as a virtual data center in the cloud. That's all it is. Now, we've been using VPCs without really sort of knowing it throughout the rest of the course. Whenever we've been deploying EC2 instances, we've been doing that into our default VPC. So every region in the world has a default VPC. You get that set up when you first set up your AWS account. Amazon provide it for you automatically. So let's look at what Amazon's definition of a VPC is. So Amazon's VPC lets you provision a logically isolated section of the Amazon Web Services cloud where you can launch AWS resources in a virtual network that you define. You have complete control over your virtual network environment, including selections of your own IP address ranges, creation of subnets, and configuration of route tables and network gateways. Now, if you don't know what those are, don't worry, we're going to come to it as we go. You can easily customize the network configuration of your Amazon virtual private cloud. For example, you can create public-facing subnets for your web servers that have access to the internet and place your back-end systems such as your databases or application servers in a private-facing subnet with no internet access. You can leverage multiple layers of security, including security groups and network access control lists, or NACLs as I like to call them, to help control access to Amazon EC2 instances in each subnet. And we'll go through a network diagram in one more slide. Additionally, you can create hardware virtual private networks, or VPN, connections between your corporate data centers and your VPC and leverage the AWS cloud as an extension of your corporate data center. So what does a VPC look like? Well, we've got a network diagram here for you, and I'll just run you through it. So on the outside, we've got our region, and I've used US East 1. And inside our region, we've got a VPC, and we're going to go in and provision this VPC as we go. So this VPC is called A Cloud Guru. The address range is 10.0.0.0/16. So this is a CIDR address range. And what I'm going to do is I'm going to go through and show you a cool website in the next video as to how you can calculate your CIDR ranges. So we've got our VPC, and it's always going to be using the 10.0.0.0 network address range. And so how do we connect into this? Well, there's two ways we can connect into this VPC. We can connect in using an internet gateway, or we can connect in using a virtual private gateway. Our internet gateway is exactly what you think it is. It provides us internet access. Our virtual private gateway is where we connect in using a VPN. Our traffic is then sent down to a router or a router, depending on where you're from. And we then go in and configure route or route tables in here. And we're going to do that in the next section of the course. And then basically your traffic goes through the route table, through a network ACL, and then it will hit your public subnets or your private subnets, so hit your individual subnets. So in here, we've got a public subnet, which means it has internet access. In here, I've got a private subnet, which means that it's only accessible via a VPN or some other mechanism. You could go in through the internet and then basically SSH from your public into your private, and that's what essentially jump boxes or bastion servers are. We obviously then inside our subnets have our security groups, and these then protect our instances. So that's all a VPC is. It's basically a virtual data center in the cloud. It consists of a bunch of different things. So you've got your VPC, then you've got your route tables, you've got your network access control list, you've then got your different subnets, and then inside your subnets you have your security groups. You have your instances. Your security groups can span subnets. That is something to bear in mind. But obviously, one subnet always equals one availability zone. And I like to say that over and over again in the course, but that is the truth. So you cannot have 10.0.1.0 being in multiple availability zones. It's just going to sit in one availability zone. So you can see here we've got our subnetting address schemes. So we've got 10.0.1.0 sits in one availability zone, 10.0.2.0 sits in another availability zone. And Amazon basically allow you to use a bunch of different internal IP address ranges. So you can use the 10.0.0.0, you can use 172.16.0.0, or you could use the 192.168.0.0. Bear in mind the different prefixes here. So this will give you the highest address range because it's a /8. This will give you a medium address range because it's a /12, and this will give you a smaller address range because it's a /16. And in fact, rather than showing you in the next lecture, why don't we just go over to this website quickly. So this website is called cider.xyz. You just go to that URL and you'll be able to access it. It's very colorful, very visual. So what you would do is you put in the address range that you're thinking about having for your VPC. So I like to use the 10.0.0.0. And then we do our /, and then what are we going to have it as, what subnet are we going to have? So the minimum that we can have, or the largest I should say that we can have, is a 16. So our very first IP address in this would be 10.0.0.1. And our very last IP address would be 10.0.255.254. And in this VPC, we would be able to have 65,536 IP addresses. Now, I know what you're thinking. What happens if I want more? Well, don't forget, you can have multiple VPCs inside a region. So you don't not just limited to one. You can have, by default, there's a soft limit of 5, but you can get that increased by emailing AWS. So you can have more than 5 VPCs in a region. So it's really up to you what you want to do. /16, /24. The most that you can go up to with Amazon is a /28. So that's the smallest IP address range that you can have with Amazon. And that will give you a count of 16 IP addresses. Your first being 10.0.0.1 and your last being 10.0.0.14. So do check out this website, cider.xyz. It's really great for planning out your VPC architecture without having to worry about all the subnetting stuff that you had to learn when you were doing your Cisco certifications. Okay, so we've learned that a VPC is basically a virtual data center in the cloud. We can create subnets. Each subnet goes into different availability zones, and then our subnets can have different network addresses. So 10.0.0.1.0, 10.0.0.2.0, etc., etc. So what else can we do with our VPCs? Well, we can launch instances into a subnet of our choosing. Like I just said, we can assign custom IP address ranges in each subnet. We can configure route tables between the subnets. So route tables basically say which subnets are allowed to speak to which other subnets. You can specifically stop one subnet being able to communicate to another subnet within a VPC. We can create an internet gateway and attach it to our VPC. Be aware that you can only have one internet gateway per VPC. There are all these silly questions out there, like saying that your internet's running slowly. What should you do? Should you add an additional internet gateway to speed it up? You can't do that. You only get one internet gateway. Internet gateways are by default, highly available, so they are spread across all availability zones. So you're not going to have if you have an outage in one availability zone, it's not going to knock out your internet gateway in another. You're going to get much better security control over your AWS resources. This is because you can use things like network ACLs to block specific IP addresses, for example. You can also, move instances into private subnets, so that stops people from being able able to access them. Our instance security groups we can deploy inside our VPCs. Remember, a security group can span availability zones. So you can have a security group across multiple availability zones, and by therefore the definition, you can have security groups spanning multiple subnets as well. You also get subnet network access control lists, and using these NACLs that you can go in and block IP addresses. So what's the difference between a default VPC and a custom VPC? So our default VPC is a user-friendly, basically Amazon provision it for us in every single region when we first set up our account. Every single subnet in our default VPCs are internet accessible. Amazon do that so that we don't get confused. So you can deploy an EC2 instance into a default VPC in Japan, and every availability zone in there will be internet accessible. You do not get private subnets in default VPCs. You have to go in and set them up. Each EC2 instance will always have both a public and private IP address when we deploy them into our default VPCs. But if we have a custom VPC and it's just a private subnet, we won't get a public IP address. We'll only get a private IP address. So now with VPCs, I mentioned earlier that we can have multiple VPCs. We might want to do that if we, want to isolate one set of resources from another, but maybe those resources need to talk to each other. Well, they can. You can peer VPCs, and this is one of my favorite emojis in the world, the little detective. So you can peer from one VPC to another. It basically allows you to connect one VPC with another via a direct network route using private IP addresses. So I could have an instance on one subnet inside a different VPC that could communicate to another instance inside another subnet inside another VPC, and that would do that over a private IP address. Instances behave as if they are on the same private network when you peer VPCs, and you can peer VPCs with other AWS accounts as well as other VPCs within the same account. So you can have a completely separate AWS account with a completely separate VPC, and you are able to peer directly to that VPC in that other AWS account as well. And peering is always in a star configuration, or a hub and spoke model, sometimes it's called. So you always have one central VPC, and you peer that out with 4 others. So we have no transitive peering, and I'll just show you what that looks like. So here we go. We've got assets in VPC A. VPC A is peered with VPC C and VPC B. So VPC A is able to talk to instances in VPC C as well as VPC B. However, an instance in VPC B would not be able to talk to an instance in VPC C. The only way we could do that is to peer VPC B with VPC C. So we don't have transitive peering with VPCs. We have to peer each VPC with each other. So I hope that makes sense. So we're at the end of our VPC introduction. So don't worry if some of this terminology seems foreign to you or strange. As you go throughout the course and get hands-on experience, you're going to get a lot more, you're going to understand it a lot easier. The best way to learn is to get your hands dirty, which is what we're going to do in the next lecture. So think of a VPC as a logical data center inside AWS. It consists of internet gateways or private gateways, route tables, network access control lists, subnets, and security groups. It has one subnet always equals one availability zone. So do remember that. It's critical going into all of your exams to understand that. Security groups are stateful. Network access control lists are stateless. So what do we mean by that? So if I was to open port 80 up on my security group, automatically I can both send and receive port 80. I don't have to open up port 80 on my inbound rule list as well as my outbound rule list. With network access control lists, I have to do that. I have to both open both inbound and outbound ports, and we'll have an entire lecture on that as we go. And always remember going in to your exam that there is no transitive peering. So that's it for this lecture, guys. You've done really well. Let's get our hands dirty and start building our very first VPC.